And we'll start by looking at the definition of a fluid. So, beginning with the definition of a fluid, what we'll do is we'll look at one of the characteristics of a fluid that distinguishes it from a solid. So what we'll begin with, we'll draw two pictures, one with a solid and one with a fluid. So we'll begin with the solid on the left, and it will be a planar solid, and let's assume that the bottom surface here is fixed. And then on the right we'll do a very similar diagram. Again, the bottom surface is fixed, but in this case what we will assume is that there's a plate on the top and the fluid is between the two plates, whereas the solid itself, the solid consists of the matter that we're looking at here. And what we'll do, we'll draw two lines in the solid and two lines in the fluid. And then let's assume that we exert a force on the top plate. So here we have the top of the solid and this is the top of the fluid. And what we're going to do is we're going to assume that we are going to exert a force like this and like that. And we'll compare what happens between the two different substances. So in one case we have the solid, in one case we have the fluid. Now in the case of a solid, we've probably done similar experiments, but assuming that the solid remains in what we call the elastic deformation zone, you'll find that the solid will shear something like this. And if you were to remove the force, what would happen is the solid would return back to its original shape. So that is what would happen with the solid. Now with the fluid, it's a little different. If we apply the shear to the upper plate, so we're dealing with this upper plate and we're applying a force going in that direction, what will happen is the fluid will continue to shear with time. And so if we were to look at this at an early point in time, we would have a shape like that. And if we looked at a later point in time, let's say this is T2, we would have something that looks like that. So what I'll do, I will label this vertical line to begin with as T0 or T0. The red one will be time T1. And finally, the blue one we'll call time T2. And we can then write that T2 is greater than T1 greater than T0. So what that shows is that as we continue to apply a shear stress to a solid or a tangential stress, to a fluid, the fluid will continue to deform. And if we were to remove this force, the fluid would remain deformed. It would not go back to the initial state as it did with the solid. So that is one of the aspects of a fluid that distinguishes it from a solid. So another aspect about fluids is fluids comprise the liquid and gas phases of the forms of matter that we normally encounter or that we would encounter. So a fluid can be a liquid, water being an example of that, or it can be a gas such as air. So we can have a fluid being either a liquid or a gas, and here I say or vapor. That would be the case if, let's say, you have superheated steam or something like that. And consequently, fluids are either liquids or gases. And when we're studying fluid mechanics, we will be studying both fluids that are not moving, and that is called fluid statics. And we will also be looking at fluids in motion, and that's where it starts to get kind of interesting. And we refer to that as being fluid dynamics. But this course is an introduction to fluid mechanics, so we'll be looking at both statics, fluid statics, and fluid dynamics. So that is a brief introduction to fluid mechanics. Fluids deform and they continue to deform, unlike a solid. With the solid, if you remove the shear, it will go back to its original state. And what we'll be doing is we will be looking at fluid mechanics consisting of fluid statics and fluid dynamics, and a fluid could either be a gas or a liquid. In the next segment, what we'll do is we'll take a look at why you may want to study fluid mechanics, and I'll show you a number of different interesting applications of fluid mechanics in that section.